Hello and welcome back. In this final video on product and quotient rules, we'll be looking at an application for the quotient rule, one that will come up from time to time. So if you're given a function that's, for instance, the cost of producing X items, then the average cost of producing X items should just be the total cost, which is going to be this function c of x, divided by how many items you've produced, which is going to be x. And this doesn't just have to be the cost of producing some items, it could be the profit or the revenue. It could be anything. C of x could model just an amount of something, and if we want that amount per thing, we simply divide it by the number of things, which is going to be x. So in general, if we want an average, we just have to divide by how many things we're taking the average of, and we have to divide the total by however many things we're taking the average of. So dividing by x will quite often give us our average. So let's just work through an example. So let's say that the cost of producing X toys at Santa's workshop is going to be given by 200 plus the square root of X. So what we want to do is find the average cost of producing X toys and the rate at which the average cost is changing at X toys. First of all, if the cost of producing X toys is given by 200 plus the square root of X, that means that the average, so this was the cost, the average cost is going to be c of x divided by x, which is 200 plus the square root of x over x. Cool. So that's the average cost of producing X toys, but the rate at which the average cost is changing. So when we're trying to find a rate of change, what we mean is the derivative. So what we want is the derivative of the average cost. So what we'll do is we'll start taking a derivative. The derivative of c of x divided by x is going to be, again, we'll use our quotient rule, so we take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So far so good. Let's do some substitution in here since we know what c of x is. So this is going to be x times the derivative of 200 plus the square root of x minus 200 plus the square root of x, I'm running out of space here, times the derivative of x, all over x squared. So again, I've just replaced c of x with what I know that it's equal to, and let's start taking a derivative. Well, I'll take x times the derivative of this function here. So if I take the derivative of 200 plus the square root of x, I'll just take the derivative of each one. So the derivative of 200 is 0. And the derivative of the square root of x, remember that x is x to the 1/2. So it's going to be 1/2 times x to the negative 1/2, which is just 1 over the square root of x. And we're going to subtract 200 plus the square root of x times the derivative of x, but the derivative of x, that's just 1. Okay, so all that's pretty easy, and we're going to divide by x squared. So let's keep simplifying. 0, that just goes away. Anything times 1, that's just that. So x times this guy, so this is going to be x over 2 the square root of x minus 200 plus the square root of x all over x squared. But x over the square root of x, if I rewrite this, x is just the square root of x squared. It's one way of writing x down. And then I can cancel 1 off the top and the bottom. So this is just going to be 1/2 times the square root of x minus 200 plus the square root of x. All over x squared. And then square root of x and 1. I made a mistake here. I have a negative sign. So I need to be subtracting. So here I've got minus sign. So 1/2 x minus the square root of x. That will be minus 1/2 times the square root of x minus 200 all over x squared. And this is pretty much as simple as I'll be able to make it. So there we go. That's going to be our average cost. Sorry, this is going to be the rate at which our average cost is changing. So let's look at a couple of values. So let's look at 100 toys. So what is the cost at 100 toys? Well, that's just going to be the cost of 100 toys is going to be 200 plus the square root of 100. Square root of 100 is 10, so that cost is going to be 210. I don't know, maybe North Pole dollars. The average cost is going to be we're going to divide by 100. So it costs an initial cost of $200 to start making toys, but then for each additional toy, it only goes up a little bit. So the average cost here, after we divide by 100, is going to be what, 2.1. So the average cost of making 100 toys is only going to be 2.1, which is quite small in the grand scheme of things. But the rate at which we're changing the derivative of this guy, if I plug in 100 into here, it's going to be negative 1/2 times the square root of 100 minus 200 all over 100 squared. So simplifying this is going to be square root of 100 is 10 times 1/2 is going to be 5. So this is going to be minus 205 over 100 squared. That's a lot of zeros. So it's going to be negative 0.334. So this is how much the average cost is changing. So when we look at the average cost is going to be 2.1, let's say, dollars. But for every new additional for the next toy, that average cost is going to go down by this much. It's going to go down by 0.205. We know it's going to go down because this is a negative number. So the average cost is decreasing as I'm making more toys. So in this instance, it's more efficient to produce more than 100 toys because we know that the average cost is going to go down. And this is just an example of the use of the quotient rule for finding average costs and the change in average cost.